Left off when we hadn't quite finished these story problems in this section. So it says, suppose you know that a population of termites is growing continuously. So yes, when you do see something that says growing continuously, that's the PERT equation. So we should use that equation. All right, so we're going to do A of t equals P e to the RT. And then it says the pest control company estimates that the number of termites will double in 6 months. Okay, so that means if we start with P, or you could put any number in there. You could put 1 termite, 1,000 termites, I don't care, 100. Then we get double what we started with after 6 months. So we're going to do t in months. So I added that to my notes. You guys see what it says? Let t be in months. So that way we can just put 6. So when you're making choices like that with these exponential functions, just make sure you're consistent throughout the problem. If t is in months, make sure t is in months throughout. All right, so when we divide by 2, we end up getting, not 2, p, we end up getting that 2 is equal to e to the 6 times r. Okay, so we did this in Algebra 2. But really I should move this problem until after we talk about logarithms. Because if I really want to solve for r, what do I do next? How do I get the r like down? Yeah.
Doesn't e go to the other side with natural log?
Yeah, so like we get rid of the e by taking the natural log of both sides. Do you guys remember that? So we would do like natural log of 2 equals natural log of e raised to the 6r. And that natural log of e cancels. Now, does that mean 6r is just hanging off in space? No. So if you remember with our laws of logarithms, if I have something like log of 8 to the 7, I can bring that 7 to the front. Okay, do you guys remember that? That's why we kind of invented logarithms. We're able to drop exponents. All right, so we have natural log of 2 equals 6r. So I get r equals natural log of 2 divided by 6. So we're going to find this number. So on your calculator, maybe I should use my calculator on here, do natural log of 2 divided by 6. So everybody try it along with me because I'm going to show you how to store values if you don't remember. So natural log of 2, do you need one? Yeah, one. And then divide by 6. Okay, so I get this 0.1155 number. Do you guys see that? Okay, and I can write that on here. I can say like approximately 0.1155. But the tricky thing with exponential growth is if you round that number, your answer, like after 10 years or 15 years, like whatever we're dealing with in months in this case, could be way, way off. Okay, because when you raise something to an exponent, it's going to change your number a lot if it's off. Okay, so we always want to store these values. And this is just a good thing to do in general, because when you go on to AP Calc and so on, we're going to have nice, precise answers. Is that one? Okay. So we're going to store this value. So on your calculator, do you guys see along the left-hand side, there's a button that says STO, S-T-O. So we're going to do STO, and we're going to store it as like alpha A, alpha R, if you want for rate, it doesn't matter. So I do alpha and then A. Do you guys see what I'm clicking? So alpha, A. And so it comes up with like a little arrow and it says A. So I'm going to hit enter, and now that's stored as A. So whenever I need that rate, I can just go back and hit A. Does that make sense? So we're going to do that a lot in pre-calc, so make sure we know how to store. Did everybody see it? I know it's kind of hard with the green screen. All right, so I've now stored that as A. So you can write a little note there. You can be like, okay, that's stored as A. So that's our monthly continuous population growth. So the second question says, well, if the current number of termites is 4,000, determine the population in 3 months. So that means we have our A of t equals P e to the r times t, and our r is that A value times t. So sometimes I kind of write like A and I circle it, or you could write that 0.1155 t if you want. And it's saying, well, if I start with 4,000, how much do I have after 3 months? So I write the amount after 3 months on the left-hand side. And so just be careful, because the way that I put this in is a little tricky. So I put the parentheses around the 3. I would probably do like times 3 and then put parentheses there. That way when you put it into your calculator, it's going to be correct. Does that make sense? Okay, and we're using that stored value. So here's what I'm going to do. So I'm going to do 4,000 I'm going to do my e, so that's always with the natural log. And then I'm going to raise it to the a times 3. Now, some of you guys have calculators where you can go up and grab. That's fine. If you want to go up and grab that number, that's fine. Or you can store it. So we get 5,056.854. Oh, no, wait, 5,656. 5,656. 0.854. Do you think I should say that for termites? Because my units are termites. Should I be like, oh, 0.854 termites? No. So let's say 5,657 termites. You can round up or round down. If you're like, well, I don't quite have a full termite, you can round down if you want. All right, so it says the Pest Control Service states that their treatment method will cut the number of termites in half every 10 days. So it says using the continuous growth decay function again, determine the daily continuous decay rate for the termite population under this treatment, round to 4 places. So if I'm cutting in half every 10 days, that means I start with my same A of t equals PE to the RT, and I'm going to have half of what I started with after 10 days. You see it? Yeah.
Wouldn't it be like 1/3 because we've been using months for time?
Oh, yeah, that's true. So 10 days, we have been using months. So let's be consistent with the problem. So if I have 10 days, I don't know how many days are in a month. Question. Yeah. So do we know? So yeah, we'll use 1/3 there. So since we're in months. That way, if I wanted to use those two equations in like together to figure out like when are we going to have 0 termites, then we could do that. But I guess this is kind of like a new problem too. If you wanted to use 10 and then use days for the getting rid of the termites, that's fine.
Oh, so it doesn't matter?
It doesn't matter as long as you're now consistent for this part of the problem.
Oh.
Yeah, but if I went back, so like in part B, if I had then said something like 30 days, then I would put a 1 here. Because I found that rate, that 0.1155, in terms of months, okay? So I would want to use everything that uses that 0.1155 with months. Okay, but if I'm finding a new rate now, I can just make sure that that's in days or whatever. Does that make sense? All right, so we'll leave it as 1/3 though, because I think that's a good catch. So we'll do that. So I have 1/2 e to the 1/3 r. And I would again do natural log of 1/2 equals natural log of e. It's going to cancel. So I get natural log of 1/2 divided by 1/3 gives me my r. Because I had a 1/3 r here, so I want to get rid of that 1/3. Now dividing by 1/3 is the same as multiplying by 3, so you could write this as 3 natural log of 1/2. And again, we can find that. So if I find that, I do natural log of 1/2, so I could do like 0.5. I take that answer and I divide by 1/3, which is the same as multiplying by 3 if you'd rather do that. So now it's a negative number, so I get negative 2.079. Okay. So that's an important thing to notice about the PERT equation, the PE to the RT equation. If R is positive, it's growth. So the termites were growing with a positive rate. If R is negative, it's decay. So the termites are being killed off then. Does that make sense? All right, so you can always tell if it's growth or decay by looking at that R value. All right, so we did number 2. We did number 3, right?
Yeah, and 4.
I don't think we did 4 because we didn't talk about how long it takes for his investment to double. I don't think we finished it.
No, because
Yeah.
we need to use logarithms or something.
Yeah, we'd have to use logarithms, yeah. So are you guys feeling okay with logarithms? Do you think we can do it? We're going to learn logarithms today, so let's go ahead and do it. So it says Ben invests $4,500 in a savings account that's 3.98% interest compounded daily. So we have A of t equals P times 1 plus r over n to the nt. And the reason I know it's this formula is because it's not saying compounded continuously, it's saying something like compounded daily. So daily, quarterly, yearly, monthly, right? These are all this formula. So he's investing $4,500, and we want to find how long it takes for it to double to 9,000. Our rate is 0.0398, 365 days. And we're finding how long it takes. So what I was saying yesterday is if you didn't have logarithms, you could solve this like using a graph. Okay, and that's why like in Algebra 2, I always gave you like a calculator section and a non-calculator section, because some people are sneaky and just like graph everything. So it's like their tutors teach them how to use a calculator and then they just go for it. So you could go to y equals, and you could put in like 9,000, and you could do 4,500, or you could simplify both sides and like divide by 2. And you can do 1 plus 0.0398 divided by 365. And then you can raise to the 365t. All right, and then you can graph it. But the only tricky thing is you would have to think about like your window. Okay, so sometimes people like to like subtract the 9,000 over, so that way they're looking at the x-axis only. But I would be thinking about what these units are. So t is our number of like how long it takes, his number of years it takes, or how long will it take for his investment to double. So t is probably not going to be like 150 years. That would be very sad for Ben. So I would say like you can make your window go up to like, you could do like 0 to 50, I don't know. But then our y's, do you guys see how the first y1 that we had was 9,000? We need to go up real high. So I would go up to like 10,000 for my y's. So I would do like 0 to 10,000. So these are just kind of graphing calculator skills. Do you guys understand what I'm doing? And then you would graph, so the first one is that line, y equals 9,000. And then the second one is this point right here. And you would do second trace, and you would find that intersection point. So you do second trace intersect. And you would go over here, and you'd be like, okay, what's my answer? My answer is x equals 17.417. So we'd say, oh, the time is 17.417 years. Okay, that's a long time. All right, but what I'm saying is today we're going to be talking about logarithms. Okay, and logarithms are a review of something that you've already seen. You've done this in Algebra 2. Is it kind of a distant memory, like you kind of remember logarithms a little bit? Do you remember all the different rules for logarithms? There's a lot. All right, so we would divide by 45, and we would find that number. So I'm finding it on my calculator. So I'm doing 0.0398 divided by 365. I'm adding it to 1. I get this number, which, I mean, I have more decimals there, so I'll kind of keep it there. And then I have my exponent that's a variable. So that's always an indicator that I need to take a logarithm. Okay, so I could switch forms. I could switch from exponential to logarithmic. Do you guys remember how to do that? Like if I gave you log base 2 of x equals 5, do you guys remember how to switch forms? 2 to the 5 equals x. So you could switch forms. So this would be like log base 1.000109 of 2 equals 365t. Like you could do that. But most of you guys didn't like that. You preferred to just take like the natural log of both sides. So we'll do that. So I'm going to do natural log of 2 equals natural log of the 1.000109 number. And it was raised to the 365t, so that now goes in the front. Because exponents can go to the front. And so we take our natural log of 2, and we divide by the natural log of that 1.001 number. And then we divide by 365, and what do we get? We get this 17.417. Okay, so if you have the calculator, like you could do it with the graph as well. Like that's fine. And that's kind of the choice that like my AP Calc students have to make a lot. It's like, is this easier, like faster to actually solve this by hand? Like to go ahead and find it using the, I guess not by hand, but using the calculator, like using the rules of logarithms and natural log of both sides and so on? Or is it faster to just graph? What do you think makes it not fast to graph it? What did I know to do, but you guys maybe didn't? Yeah? What do you say, Sam? Typing it all in. The window. That's the thing that students are not the best at. Because maybe you don't understand, like, oh, wait, my y equals 9,000. I have to go all the way up to, like, 10,000. Does that make sense? So those are the skills that you guys get better at. So that's why we'll continue using it. All right, so number 5. So use the law of exponents to determine which functions, if any, are the same. Okay, so we have some laws of exponents. So this first one, y equals x 5 to the x plus 2. Do you guys know the rule that says if I have x squared times x to the 5th, it's x to the 7th? We add exponents, don't we? So if I had something that looked like x to the 2 plus 5, could I write that as x squared times x to the 5th? Yeah. So this one, if I see 5 to the x plus 2, well, that's really 5 to the x times 5 to the 2. Do you guys see how those are the same? Add your exponents. And 5 squared is 25, so it's really 25 times 5 to the x, which is this one. So these two are the same. But we also had some division rules too. So we had things that said, oh, if I have x to the 7th over x to the 3rd, it's really x to the 4th, right? So let's do that on this next one. So I see that I have 25, and 25 is 5 to the 2. So if I have 5 to the 2 over 5 to the x, if I subtract my exponents, I get 5 to the 2 minus x. Right? Well, that's the same as the one over here, right? So maybe we'll do another symbol for that. So these two are the same. Okay, so let's try this last one. So if I have y equals 5 to the x plus 4 over 25, again, I can subtract my exponents, but I need to first see the 25 as 5 squared. So when I subtract my exponents, I get 5 to the x plus 4 minus 2, which is 5 to the x plus 2. So what's it the same as? It's a check mark, right? Exactly. Does that make sense? So the frustrating thing for students when they take like AP Calc is that the answers could be in any of those forms. So it's like there's not really a consistent form for those answers. And so sometimes my students will get the correct answer, but they'll spend so much time like thinking, wait, which one is it the same as? So you can always plug in numbers. Like if you want to plug in 0 and kind of eliminate things, like you can be like, oh, when I plug in 0, I get 5 squared, that's 25. When I plug in 0, I get 25 over 5, or 25 over 1. Like you could plug in some different things and see if they're the same. I guess 0 is not a good one, but 1 or 2. All right, so last one. So it says if you invest $100 at 3.34% compounded monthly, what is the percent gain you made after a single year? So again, compounded monthly, so we write our A of t equals p times 1 plus r over n to the nt. Do y'all have that formula memorized again? You're like, no. I do make you memorize it in pre-calc. Last year in AP or in Algebra 2, I told you I would make you memorize it. Do you guys remember this for the test? And then I put it on the test. I'm not that nice in pre-calc, so you do need to memorize it. That's a whole year of practice, right? I'm sure this is what you guys do on the weekends. Bust out this formula. No? No one? Oh, funny. That's what I did in high school. But, you know, I wasn't really cool. All right. So we want to find the amount that we make in a single year, so A of 1. So you can write times 1, or you can leave off the times 1. All right, so we do all this. So you already know. Yeah, but I forgot. Oh, did he? Well, Maury was in the financial world for a very long time, so Maury probably really likes those formulas. Do you guys know that? He was an accountant before being a teacher. Yeah, he did pretty well with it. That's what supported him to be a teacher. See, us that just start out as teachers, we don't really think that through, and then we feel real poor in about 10 years. We're like, oh man, I got kids. Kids are expensive. So he made the money first. That's smart. I should have done that. All right, so anyway, so 103.39. So it's saying, what is the percent gain? Would I say that, though? $3? I would say 3.39%, right? Because I started with $100. That makes it easy when you start with 100. Right, that's how much I gained. All right, that's what we're going to call APR eventually, or APY. All right, so let's stop there. Oops, not my calculator.